Welcome to an introduction to modular synthesis and modular synthesizers with me, Steve Munslow. I'm sitting here with my part of my modular setup. I have another case over there, which I'm not going to show you because it's a bit messy over there at the moment. Yeah, I have a bit more equipment over there. And so what is modular synthesis? What is a modular synthesizer? Well, it is individual building blocks or modules that each do a certain thing, have a certain job, and you can interconnect them using various patch cables, as they're called, or different lengths. I've got small ones, long ones, ones in between, and you connect all these building blocks, all these modules together, and there's my cables there, and you make music or noise. But we'll start with the first basic building block, which is the oscillator. This is the thing that makes the sound that you are going to manipulate with all the other modules in the rack. You don't have to have an oscillator as the first thing making the sound. There's lots of other ways of doing it, but we will start with oscillators because it's probably the most basic thing. Now I've actually got 3 oscillators in a row here. There's that one, that one, and that one. And this one here we're going to concentrate on. So it's quite simple. It's a nice simple analog oscillator. It has 5 waveforms come out of these here. I've got the square wave connected up, and if I turn this up, it'll make a noise, and that's for tuning. And at the moment it's just kind of droning, it's just making a noise, and it's the other equipment that will make it make different noises. But it does have 1 or 2 little tricks up its sleeve. So here it has outputs called saw and pulse. Then we put it in the pulse and turn it up. Can you hear the way that's? Now what if we could automate that so I haven't got to twist it with my hand? Well, what we do is we do what we call modulate it. We use another piece of equipment to automate that process. So what I will do, I'll grab one of my patch cables. Don't worry about what this piece of equipment is at the moment. I haven't set this up beforehand, so I have no idea whether it's going to work properly or not. We'll find out. Already we can make it make some quite interesting noises just by 2 things. You will notice that this oscillator has the legend at the top there, It says VCO. Now that stands for voltage controlled oscillator, and it's voltage control that we're mostly interested in modular. Well, in synths in general, everything is voltages. So what you're doing is you're using one voltage to control something else. And it's important to know what you can and can't do with voltage. You can only basically do three things with it, which is keep it the same, increase it, or decrease it. Now you could say, well, I can switch it off, but in the modular world, 0 volts, switching it off, actually means something. So that 0 volts is a voltage. So we can make it more, make it less, keep it the same. You can do it in lots of different ways, which is what I was doing here. This is a module. It's quite a common. A lot of people have this module and for good reason. It's called Maths, and it does. I'm using it as a very, very basic modulation source at the moment, but it does a lot of things, and it can look quite confusing at first, but once it's broken down into its component parts, it's actually quite straightforward. But it does a lot of things. It can do a hell of a lot, and it's certainly it's very rare that I will set up a patch on the modular without using Maths. It's very, very good, even if you're just using it in its most basic state. So we have the VCO, the voltage controlled oscillator, and it's making that noise now. So we'll keep it doing that for a bit. And we'll take the output from that and we'll put it in here. Put it in the right one, it might help. We'll take the output now this. I'm going to get plugged into this one on the right here, which is a filter. It's what's known. This one in particular is what's known as a state variable filter. It's got three filters on it basically that all run together. It's got a low pass filter, which is what I'm using here, which, as the name suggests, will pass lower frequencies while cutting higher ones. Now, the purpose of a filter is to shape the sound, and you have what's called the cutoff frequency, which is what and that cuts the frequencies around what's called the resonance. You hear those peaks in the sound? That's where I'm adjusting the resonance, and this is where I adjust the cutoff. And again, we can use our maths to automate that manipulation of the cutoff. So I'll see how it goes. So there we're using the same control voltage to adjust our pulse width on our oscillator and to adjust our cutoff frequency on the filter. Now if we wanted to actually play some notes, play some sort of tune if you like, we need a keyboard perhaps, or you can use a sequencer. That just sends a sequence of control voltages to the equipment. It's commonly used for notes. It doesn't have to be, it can be for any control voltage. But if we want to send it notes, then what shall I use? I've got, as you can see, I've got quite a few sequences here. Everything in this this one here is basically things to control other things. I have one of the essentials of modular synthesis actually is this clock, which is what it says. It determines the relative speeds of everything. I use one called Pamela's New Workout. It's a fabulous little piece of kit. So I will send a clock to a sequencer, set up a quick sequence, throw it into our oscillator and see if we can get some sort of tune. Now, as you can hear, that's not really in tune. It sounds quite horrible. And the reason for that is that this just sends this particular sequencer just sends whatever I dial into the knobs there. It just sends that voltage out. So what I need is some way to take that voltage and make it more musical. And what you do, the most common way of doing that is something called a quantizer. And what a quantizer does is it will take those 8 voltages that I'm sending out from this sequencer and it will convert them into a musical scale. So it'll take the nearest note that voltage represents within the scale and output that, so it becomes a more musical sound. So I can connect that up. Have I got long enough? No, it's not long enough. I need a longer one. There we go. And we take this. So now I'm going from the sequencer to the quantizer, and well, that was horrible. Let's try something. Let's try again. It still doesn't sound great because all the notes are blurring into each other. There's no sort of dynamic there. It's just very flat. And that's because we haven't got what are called envelopes. We don't have an envelope at all working on this, or any form of dynamics. And what I'm going to do here is I'm going to send it to if I can find out where I am here. I'm going to put it through. What is known as a low pass gate. Now I have a filter on here already, and I'm also using a low pass gate. This is quite frowned upon in some circles, but it's the beauty of, to me, the beauty of this form of synthesis is that you really don't have any rules. Let's just make sure I've got the same thing going there, and let's put it through the other one. change things on the fly, just play with it. Can you hear how that almost has like a bongo type quality to it? It's one of the features of the low pass gate, that you can get this lovely almost ringing sound from it. You can still hear the filter in the background there. If I start adjusting the filter a bit, here's some of the subtleties as you make small adjustments. Let's see what happens if we try a different waveform on the oscillator. That's a square wave. Try a sine wave. Triangle. Won't be an enormous amount of difference between those two on this patch. We'll go back to our pulse width. Actually, let's try the saw. And that's just a basic patch, a very, very basic patch. We can get all these tonal variations from some very, very simple principles. Go back to the pulse width. Oh, that's nice. So let's just have a quick look at what we did here. We took a basic oscillator, okay, let's have a quick look at what we did here. We took our basic oscillator, got some control voltage to manipulate the pulse width, used the same control voltage to manipulate the filter, and then the filtered sound was fed into a low pass gate. It's a part, I suppose I should explain a bit more about what a low pass gate is, and this will also link into another piece of the modular puzzle, which is what they call a VCA, which is a voltage controlled amplifier. And the important part of that is the voltage control part. As we've seen already, the voltage control is what this is all about. And what a voltage controlled amplifier does is it takes one voltage and allows another voltage to control it. Now, the voltage that is being controlled can be audio, it's all voltage, or it could be anything else. And you use another voltage to control it. Now, in the low pass gate, it also has some mild filtering. So it's what they call a voltage controlled amplifier filter, VCAF. And the low pass gate is a quite unique module. It utilises a thing called Vactrols. It uses a light source, usually an LED, and some sort of light sensitive, usually it's light sensitive resistor. And so the LED comes on, it actuates the resistor, the LED goes off, and the resistor goes off, if you like. The effect of that, when you apply it to the audio, is that the light doesn't, it's not like a switch, it doesn't go off immediately. It doesn't take a lot of time, as we know light moves very quickly, but it's enough so that you just get this kind of, you heard that ringing sound that it made, like that kind of decay, as we call it, and that is the Vactrols. And it was originally a design by Don Buchler, and the one I'm using here is called the Low Pass Duo by Make Noise. I also have another one of theirs called the Optimix, the original Optimix. They did a Mark II. And I have another Vactrol low pass gate, which is a passive one, which I really like as well. But the low pass duo is really easy to set up, really easy to use, very nice sounding, in my opinion. So what's happening here is, let me put my camera on so I can show you the, right, so this is the low pass duo here. I've got, you see the 3 cables in here. So there's an input at the top, an output at the bottom. There's one I haven't got connected up, which is CV, control voltage, which allows it to act like a voltage controlled amplifier. You can apply voltages there and it will react to it. There's also this one here, which I plugged into. It's called the strike, and what that does is, they call it, you ping the Vactrol, and it gives you that sound, and yeah, really good. So your strike, it's called the strike input. It strikes the Vactrol, as they call it. So it just comes on. The light, the LED inside that Vactrol just comes on, and then it gives you that natural decay. Well, we made a noise, and I hope you found it interesting. Just a brief introduction. If you did find it interesting and you'd like to know more about any of the particular modules or any of the principles I've been talking about, then please, just get in touch through whatever medium you found out about this, and I'm happy to answer any questions. There really is no right and wrong with this stuff. It's there are a lot of people who get very fixated on, this is the right way of doing things, this is the wrong way of doing things. And there are a few rights and wrongs, because you could damage equipment by doing the wrong thing. But as far as connectivity and how to put things together, if you like the way it sounds, it's the right way. Simple as that. And there's a lot of other stuff here I couldn't show. We've used a very basic oscillator there. I have other oscillators that do a lot more. Here I have another module. It's a modal synthesizer, as it's called, and again, there's a lot of knobs and a lot of things. But it what that does is it simulates a bow. It simulates blowing. It simulates striking something with a mallet, but not real things. It has quite a unique sound. That'll be interesting. So it has on the side here, that's this side, where you can see the coloured knobs, and on this side is what's called a resonator, and it allows you to place the sounds within a space, add reverberation and position, damping, so that it can, if it was the mallet sounds, they're very muffled and then ringing at the top end. Very good sounds out of that. Modal synthesis. I have this module here called the Morphe Gene, which simulates old-fashioned tape. You can make, back in the days when people actually cut and sliced and pasted tape together, and you can very much simulate this with this module. It's a very I use it a lot for manipulating sample-based material rather than traditional synthesis. I have a lot of sequencers over here. I have this module here, which is a standalone synth called the Zero Coast, or the O Coast, or the No Coast. No one seems to quite know quite know what its name is. Again, it's Make Noise. Very, very a very, very good piece of kit. This it's a very good starting point for anyone coming into modular synthesis, because it will play without any cables in, but you can patch it and repatch it to make different sounds, and it comes supplied with cables and everything you need to get started. Very good. I also have a Erica Synths Pico System 3. This is again a kind of everything in one box, although you have to patch it to get anything out of it. It won't just play as is. But again, if you buy, it comes in two. There's a Eurorack version, which is obviously the one I've got here. Well, there's a desktop version that will stand alone, and you get some cables and bits and bobs with the standalone one. And very good, extremely good way to learn modular synthesis. And that's really with the design principle behind it. They want it to go into schools and colleges to as a synth to learn about synthesis, and it's extremely good. So again, any questions, please ask away. Anything you want to know about. If I know it, I'll tell you. If I don't know it, I'll tell you as well. I don't profess to be an expert. There's no such thing in this. You learn all the time. I've been doing synthesis for 45 years now, and I still don't know it all. Anyone that says they do is a liar or a big head. And on that note, goodbye, and I hope you enjoyed it.